Hi everyone, welcome back. In this video, you're going to identify the key features of a polynomial given its graph. Okay, and this is an example of a polynomial, a third degree polynomial. Okay, and this third degree polynomial is special. We call that because it has it has a triple root at x equal 2. Why do I say that at the x-intercept of x equal positive 2, we have a triple root? It's because, as you can tell, okay, the polynomial, the line of the polynomial function is crossing over the x-intercept, okay, in a curve. I hope you can see the curve that's happening right here. So the one way to recognize a triple root, you see that the function, the polynomial function, is crossing over the x-intercept in a curve. Okay, remember that a double root, the polynomial is going to bounce back down, or it can also bounce back up. Okay, it's basically making a U-turn. So for this case, example number 7, okay, we have two double roots. Again, I showed you how to write the factor form for the double root and how to derive a standard form. And it was right here. Okay. So now this one is a double root. Okay. So not double, sorry, triple root. Let me write that. So triple root. So you don't forget at x equal positive 2. Okay. So at x equal positive 2. At the x-intercept, we have a triple root. Okay. Now, what is the degree of this polynomial? So again, the degree is going to be, when you're given a graph, you want to look at the end of the graph, the arrows. You can tell that the arrows are pointing toward opposite direction. So because they're pointing toward opposite direction, you see that the degree is odd. Okay, so the sign of a leading coefficient is positive. Why do I say that the sign of a leading coefficient is positive? So as you can tell, since the odd degree, you look always at the arrows on the far right. The arrows on the far right is pointing up, so I know that the sign of a leading coefficient is going to be positive. Why? The arrows on the far right is pointing up. Okay. Next, you're going to describe the end behaviors. The end behavior. How do we describe the end behavior? So you're going to look on the left side. You're going to consider the left side of 0. Okay, all the negative x value. Okay, then you're going to consider on the right side of 0 all the positive x value. So that's what you're going to do right now. Okay, so describing the end behavior, I look on the left side. All the numbers less than 0 are negatives, okay, numbers, and they keep on decreasing as you move toward the left. So as the x value goes to negative infinity, okay, the y value goes to, and you notice the arrows on the left is pointing down. You see the y value goes to negative infinity. Okay. If we're going up, you see positive infinity. Okay, so you're done describing what is happening at the end on the left side of 0. So let's consider all the number on the right side of 0. So as the x value keep on increasing forever, as our x goes to positive infinity, comma, what is happening to the y value? The y value keeps on increasing forever. Why? The arrow is pointing up. So yeah, it makes sense because the degree is like odd. So the exponent of variable x can be 3, 5, 7, 9, and so forth. So basically, if you triple the number, the output will be larger. Okay. If the number x is positive number and you triple it, you get the larger positive number. If it's negative and you triple it, you get if you cube it, not triple, but if you cube it, if you use a negative number and you cube it, you get a smaller number. If you take a positive number and you cube it, and you get a very large number. So on the right side, arrows pointing up, so I'm writing positive infinity. Now, what are the y-intercept? The y-intercept represents the point of intersection between the y-axis and the polynomial function, and it's right here. So the y-intercept is at 0, negative 8. What are the zeros? The zero represent the point of intersections between the polynomial function and the x-axis. Okay, and the 0 occur at x equal positive 2. And remember, you have a triple root. Okay, so triple root means you have x equal 2 x equal 2, comma, and x again equal 2. You need to triple the root. Even though they have the same number, but you have the same number for the x-intercept, but you have 3 roots. So what is going to be the factor form? Again, so you want to go back before applying, when you apply the zero product property. So to get to the product, the factor form, so you have x equal to 2, right? So I want it to be equal to 0. So in this case, you're going to minus 2 in both sides. And the new equation is going to be x minus 2 equals 0. So we end up with the factor form, x minus 2, okay? So you have y equal x minus 2, right? And everything cubed. Remember, you have 3 of the same factor. I didn't want to do that 2 times. So that's why I cubed it. And I'm going to multiply by a. I don't know what is a, the coefficient here. So you need to figure it out if it's a 1 or another number. So in this case, I'm going to pick a point over then the x-intercept. So another exact point on the line on the function, but not the x-intercept, because you used the x-intercept earlier to derive the factor form. So I can use a y-intercept, and the y-intercept is 0, negative 8. So now I know x is 0 and y is negative 8. So I'm going to replace that into the original function. So I end up with negative 8 equal to a, 0 minus 2 everything cubed. So negative 8 equal a. So let's do some mental math. 0 minus 2 cubed. 0 minus 2 is negative 2. And you cube it is going to be negative 8. And then you end up with negative 8 equal to negative 8a. So to solve for a here, you have to divide both sides by, again, I want a alone, by negative 8. So we end up with 1 equal to a. So the factor form is going to be 1 times x minus 2 cubed. Like I already told you in mathematics, when you multiply by 1, we drop the 1. You don't write the 1, but they assume that you know there's the 1 being multiplied here. So it's going to be x minus 2 everything cubed. Okay, so now we want to derive the standard form. So remember, you're going to use our knowledge of exponents. A cube means the base needs to be multiplied by itself 3 times. So I'm going to write y equal x minus 2 times x minus 2 times x minus 2 3 times, and then you're going to multiply. Okay, so you can, what I'm going to do, I'm going to multiply the first 2 factors together. Okay, and then when the product, I'm going to use that multiply by the with the third factor. Okay, so let's multiply here. So I have enough space. So on my far left, I'm going to use the box method because I know some of you like the box method. So please pause the video and also multiply. So I multiply and I end up with x squared, and I combine in negative 2x plus negative 2x add up to negative 4x plus 4. So remember, okay, we get x squared minus 4x plus 4, and I'm going to multiply with x minus 2. So let's do that. So because the first factor is made of 3 terms, so on my left, I drew three rows, and the second factor is made of 2 terms, so and the column I only have 2. Okay, if it was made also of 3, I have to make 3 also columns, okay? Then you're going to multiply. So let's do that together. So please pause the video and multiply. Okay, so I did multiply using the box method, and I end up with x cubed minus 2x squared minus 4x plus 8. And remember earlier we said that the degree was odd. So the degree of this polynomial, the highest exponent here is 3. So 3 is odd number, correct? It matches. And the leading coefficient means the sign in front of x cubed. You don't see a negative. So it's assumed that the sign is going to be a positive because the coefficient of the leading term is 1, okay? The coefficient of the leading term is 1 or positive 1. So that's why you have positive here. Okay. So now for the domain, and I told you I want you to use interval notation. So the domain of any polynomial, or every polynomial we have for domain all real numbers. And in interval notation, that's the way I would like you to write it. Okay. And I believe I explained that in my previous video. Okay. So this includes all negative x value and all positive x values. There's no restriction on what x can be. Okay. So that's why the domain is all real numbers. Now for the range, because we have a third degree polynomial, okay, so basically because the degree is odd, ODD, okay, the range is going to be your all real numbers. However, the range is not going to be all real number for even degree polynomial. Okay, so as you can tell here, okay, the line is going, the polynomial is going up forever. So the y value, if you go, the range go from negative infinity, okay, because the arrow keeps going down forever. So you go from any negative number from negative infinity up to, and the arrow continue up forever. So from negative infinity up to positive infinity. And that's the reason why I say that the range is all real numbers. Okay, so thank you for watching my video, and I hope it was helpful. See you into the next one. Bye bye.